The world of technology is buzzing with terms like machine learning and neural networks. These might sound intimidating, but they are actually fascinating concepts that can be understood with a bit of curiosity and an open mind. This blog will walk you through the basics of neural structures and how they relate to machine learning in a simple, easy to understand way. Let's dive in. What is machine learning? Machine learning, or ML, is a branch of artificial intelligence that focuses on enabling computers to learn from data and make decisions without being explicitly programmed. Think of it as teaching a computer to recognize patterns and make predictions, just like how humans learn from experience. A simple example of machine learning. Imagine you are teaching a computer to recognize pictures of cats. You show it thousands of images labeled as either cat or not cat. Over time, the computer learns what features like fur, whiskers, and pointy ears are associated with cats. Eventually, it becomes capable of identifying cats in new, unseen images without you explicitly telling it what a cat looks like each time. The role of neural networks in machine learning. To understand how computers learn from data, we need to introduce the concept of neural networks. These are the backbone of many machine learning models, especially when it comes to complex tasks like image recognition, speech processing, and natural language understanding. What are neural networks? Neural networks are inspired by the human brain. Just like our brain has neurons that process information, a neural network is made up of artificial neurons, or nodes, that are connected to each other in layers. The input layer is where data enters the network. Each node in this layer represents a feature of the data, like pixel values in an image. Hidden layers are the middle layers where the actual processing and learning happen. The network uses weights and biases to adjust its understanding of the data. Finally, the output layer produces the final result, such as classifying an image as a cat or not cat. How neural networks learn. Neural networks learn through a process called training. Here's a simplified version of how it works. First, we feed data, like images or text, into the network. This is known as the forward pass, where the data passes through the layers and the network makes a prediction. Next, the network calculates the error by checking if its prediction was correct. If not, it calculates how far off it was, which is known as the loss. Then, through a process called backpropagation, the network adjusts its internal parameters like weights and biases to reduce the error. It learns from its mistakes and improves over time. This process repeats over many rounds, called epochs, until the network becomes accurate. Key terms in neural networks. Let's break down some of the common terms you might encounter. Neuron, the basic building block of a neural network, similar to a cell in the human brain. Weights. These are numbers that control how much influence a neuron has on the next layer. Think of them like volume knobs, turning up or down the importance of certain features. Bias. This is a number added to the output of neurons to adjust the overall behavior of the network. Activation function, it decides whether a neuron should be activated, meaning pass information to the next layer. Common activation functions include ReLU, which stands for rectified linear unit, and sigmoid. Lastly, epoch, one complete cycle of training on the entire dataset. Types of neural networks. There are several types of neural networks, each designed for different kinds of tasks. Feed-forward neural networks. The simplest type, where data moves in one direction, from input to output. It's great for tasks like classifying images, convolutional neural networks, or CNNs. These are specialized for analyzing visual data like images or videos. CNNs use filters to detect patterns like edges, shapes, and textures in images. Recurrent neural networks, or RNNs. These are designed for sequence data, such as time series, speech, or text. They have a memory element, meaning they can consider past inputs when making decisions. Generative adversarial networks, or GANs. These involve two networks competing against each other, a generator and a discriminator. GANs are used for generating new data, like creating realistic fake images or art. Practical applications of neural networks. Neural networks are everywhere. Here are some cool real-world applications. Voice assistants, Siri, Alexa, and Google. Assistant use neural networks to understand and respond to your voice commands. Image recognition. Apps like Google Photos use neural networks to automatically tag and organize your photos. Self-driving cars. Autonomous vehicles use neural networks to interpret data from cameras and sensors, helping them navigate safely. Healthcare neural networks assist in diagnosing diseases from medical images like X-rays or MRIs. Social media platforms like Instagram and TikTok use neural networks to recommend content based on your preferences. How can you get started with machine learning? If you're excited to dive into the world of neural networks and machine learning, here are some simple steps to get started. Learn Python. Python is the most popular programming language for machine learning, thanks to its simplicity and powerful libraries. Explore libraries. Start with libraries like TensorFlow, Keras, or PyTorch. They provide tools to build neural networks without needing to code everything from scratch. Take online courses. Platforms like Coursera, Udemy, and Khan Academy offer beginner-friendly courses in machine learning and neural networks. Practice on datasets. Websites like Kaggle provide datasets and challenges that let you practice building and training models. Build your own projects. Try creating simple projects, like a program that classifies handwritten digits using the MNIST dataset, or a chatbot that can have basic conversations. Conclusion. Neural networks and machine learning might seem complex, but they are all about teaching computers to learn and make decisions from data. By understanding the basics, you can unlock a world of possibilities and even start experimenting on your own. Who knows? You might just create